Electrophoresis. The process of electrophoresis is basically movement or migration of ions through the electric field. The charged molecules move to their counter-charged electrodes, but removal of electric field is done before it reaches to the electrode. Because it can cause conformation change in molecules and their pore size can increase, resulting in electric lysis. In an electric field, when these charged species move, consequently it gives differential mobility to the sample based on the charge and resolve them. It occurs due to the phenomenon of electrostatic attraction. In other words, electrophoresis is a separation technique based on different mobility of charged molecules in an electric field. Hence, it's a separation technique mainly used in molecular biology, biochemistry, and medicine sector. The materials like proteins, nucleic acid, drugs, pesticides, organic cation or anion can be separated by this method. A pioneer work done by Arne Tiselius in 1930, and he discovered the technique of electrophoresis. In his experiment, he found four distinct bands for testing horse serum in an apparatus. The bands were of 1 albumin and 3 globulin. He was awarded with the Nobel Prize in Chemistry in 1948 for his research contributions in adsorption analysis and electrophoresis. He was awarded the Nobel Prize in Chemistry in 1948 for his research contributions in adsorption analysis and electrophoresis. General principle of electrophoresis. The technique of electrophoresis is generally based on the principle that charged molecules move to opposite charge in an electric field. The different ions and molecules migrate at different speeds based on their varying charge and masses and get separated into single bands or fractions. On applying of voltage or potential difference across the electrodes, a potential gradient E is generated, which is equal to voltage applied, that is V, divided by distance presented between the electrodes, that's D. Thus, E is equals to V divided by D. It is noted that D may vary for different equipment, and hence for the same applied voltage the potential gradient can vary. If Q coulombs is the charge on a molecule, then force newtons applied on a particle will be equal, that is F is equals to E into Q. This force results in the movement of the charged particles towards the electrode. Particles carrying positive charge are called as cations and will move toward cathode, whereas particles with negative charge are referred to as anions, and these will migrate toward the anode positively charged. The rate of electrophoretic migration depends on the following factors. 1. pH of the medium. 2. Strength of electric field. 3. Size of the molecules. 4. Magnitude of the net charge on the molecule. 5. Temperature. 6. Concentration of sample. Factors affecting electrophoresis. The velocity of this process mainly depends on inherent factors like magnitude of charge, molecular weight, shape, and charge density of the molecules. External factors like pH of the solution, electric field, porosity, viscosity, and temperature of solution. Thank you.